Sometimes you're going to be asked to combine various radical expressions with addition and subtraction. And what we're going to do is we're going to use the distributive property and the idea of like terms. Recall, with the distributive property, if we had a similar multiplier,
are you pondering what I'm pondering?
Such as, in this case, the square root of 3, if we could factor that out and be left with only numbers, we had like terms and we could combine them. And in this case, we'd combine the 5 and the 2 and we'd have 7 radical 3 because they were similar.
Now what am I going to do?
Now if you don't have that, the distributive property won't work. You have to have something similar.
Yes, you're in deep do now.
So you have to know
We can't do it.
you can't do anything.
Allow me to introduce myself. My name is Mike.
Just leave them alone and that's your answer.
Any of this sinking in, boy?
So basically all we have to do is look for similar terms. There's a 5 square root of 3 and a minus 1. Remember, when we don't have anything, it's a 1. A minus 1 square root of 3, and 5 of them minus 1 of them is 4 of them. Now here we have 3 square root of 2 and 4 square root of 2. That makes 7 square root of 2. And if there's an expression that doesn't have anything to match it, you just write it.
And that's how she wrote.
It's not so bad, is it? Just look for similar terms. Of course, you can't be sure whether you have like terms until you simplify the radicals. Let's simplify the square root of 18. It breaks up into the perfect square, 9, and the garbage left over, 2, or 3 radical 2. Looks completely different, doesn't it? If we simplify this expression, we just bring the 2 down for now, and we break up the radical into the perfect square, 25, and the leftover 5. Now, the square root of 25 is going to be 5, and then you multiply them by the 2, and you get 10 radical 5. Now this one, sometimes there's just nothing you can do. So you just bring down the garbage. But recall that if we have similar terms, we can add them.
I know that, dude.
3 radical 2 and 1 radical 2 make 4 radical 2. And we can't do anything with the radical 5, so we just bring it down. And that's your answer. So remember that you're going to have to simplify everything so that you're positive whether or not you have actual like terms.
Here is today's final Jeopardy answer.
We use the same rule whether or not you have variables or not. So we're going to have to simplify first. Hum if you need to. We're going to break this into, let's see, the 32 first I'll break into 16 and the leftover 2. I do a little bit at a time. And the x to the third I'll break into the perfect square x squared and the leftover x. Now the square root of 16x squared is 4x, and I have my leftover that I can't do anything with. Now let's look at the next expression. Bring him down, break up the radical into, let's see, 8. We'll break up into 4 and 2, and the x is all bad, so I just put him in the bad pile. Now the radical 4 is going to become 2, and once he's a 2, I can multiply it by the 4x and get 8x. And here's another example where sometimes you just don't have anything good. There's nothing good in 2 and nothing good in x. So just bring it down. Now what do we have here? We have 3 like expressions.
Is that your final answer?
No, we can combine them. I have 4x radical 2x, 8x radical 2x, and minus 1. 4 and 8 and minus 1 make 11x radical 2x.
How sweet it is.
Now everything had to be the same, but it was in that case. That's about as tough as it'll get.
What's all this jabberwocky when there's work to be done?
Okay, let's go practice that.